Hey guys, welcome back, and I have to redo this video because the original one did not take, so I apologize if there's any information that is either redundant or not covered yet. So what I want to do is create a user-defined exception. So far we have created exceptions or we've used exceptions from the Java library, but we can actually, as a developer, create our own user-defined exception. So to demo this, let's create a payments application and let's force a positive payment amount. Okay, so in my exceptions package, I'm going to create a new class and I'm going to call this payments app, and then I'll give it the main. Okay, so this payments app, we will take a payment from the user. Okay, so how do we do this? Okay, so there's just going to be a couple steps here. So first we're going to ask the user for input. Okay, then we're going to get the amount and test the value, and then we will handle exceptions appropriately, and finally we will, if we have a positive payment, an acceptable payment, then we will print the confirmation. Okay, so this will be our simple step of our outline of our payments application. So ask the user for input. So the first thing we want to do is we want to say sysout, let's then ask, whoops, what was that? We want to there we go. We want to ask enter the payment amount. Okay, now when we ask the user, when we print this on the line, of course we're going to run this here, and of course there's the enter the payment amount, the application closes. Now again, I don't know if I've covered this already in this tutorial because I'm making this video after I created the course. How do we ask the user for input? How do we get input from the user? Well, we can use the scanner utility class. So we can create a scanner object, and it's equal to new scanner using system dot in. This will create an input stream that will allow us to actually type in the console, and then then we can actually use that information in our program. So to do that, we need to import the scanner library right there. Okay, and I'm gonna say, we'll say int amount equals in, right? So in is our object. In dot now the scanner utility class, it has a couple different has lots of different options. We're interested in the next int, right? Because this is an integer, so we're interested in the next int. Okay, and now once we receive that, then we can do a print amount. Okay, so just to kind of, before we start filling in everything else, let's just run this, make sure that our scanner is working. Enter the payment amount, 25, there we go. Okay, so it's working. First thing I see here is we want this to be on the same line, so let's come back to our, when we ask, let's just, instead of print line, let's just print. So when the user enters, there we go, it's printing on the same line. There we go. Okay. Alright, so now what we want to do is, let's say in the case that we enter a negative 50. So what happens there? Okay, so first of all, what we want to do is, instead of int, we want double, right? Because what if we did something like 50.25? So there's going to be an exception here because it's not an integer. We said next int. So let's do this. Let's create a double amount, and we'll initialize it to 0. In fact, let's just call this payment equal to 0. And when we have this scanner object, we're going to say payment then is equal to in dot next double, right? Because it's a double variable we're storing this in. We want to take the next double amount. Okay. All right. So now we have taken in the amount. Now we need to go to step 2, test the value, which we want to test the value here. Okay, so we could do it the old-fashioned way, right? Where we have if payment is less than 0, then we print error and so forth. Okay, this isn't the best way to do it. It's a little lazy, and it forces the client to have to handle this. So we don't actually want to leave it up to the client. We want to be able to handle it as on the development side. So what we want to do is then we want to try, right? We want to try this value. So if we try this value, and then we can say if payment is less than 0, then we're going to throw the error, and I'll leave that up for in just a moment. And then we will want to catch, whatever exception here. Okay, so how's this going to work? I'm going to create a new class where so when we write an exception, we need to actually put that in a class, and we're going to reference that class in the exception. So I'm going to create a new class, and I'm going to call this class negative exception, or negative payment exception, right? Negative payment exception. So this should be pretty clear. This should describe what the exception is going to be. Now we don't want it to be a main, because we're actually going to create an object out of it. So it's a class, and so what we want to do is when we create an exception, we're going to create this class. So we're going to create an object. So if we want to do that, then we want to have a constructor, right? So we want to have our public negative payment exception, and then we can just say, of course this is empty, we can say return, we can just say error negative payment, or we'll print this out. There we go. Okay, so now we've actually we've created our exception. Actually, there's one other thing to create an exception, our own user-defined exception. We need to extends the exception class, right? So when we do that, now that then the exception, all the properties available to it are now available to us through inheritance. Okay. Okay. So let's come back to our payments app. Okay, so if the payment is less than 0, now here is where we actually want to throw the error. So we can just say throw new negative payment exception. Right? So when we throw the error, right? When we throw this exception, it's going to come. We're actually creating an object, right? This is new negative payment exception. So we're creating an object, and we're going to throw it, and then we need to handle it here in this our catch. So we're going to throw it in the try, and we're going to catch it here. So now we need to say negative payment exception E. Okay, and if we get into this, then we just say error, something like that, and we'll enhance this all later on as well. Okay, so let's just run this and see what happens. So I'm going to run it, enter the payment amount. Let's do 50. Everything's fine. Okay, let's run it again, and we'll do negative 25. Error, negative payment, error. Okay, so it caught the error. It didn't have a bunch of red markings, right? So this is looking good. Now let's just optimize this a little bit. So for example, when we get that toString method, right, that nice toString method, how do we handle that? So let's come back to the negative payment exception. So we want our toString, right, because often when we have an E, write this E, create this object here, the variable E, we do something like E dot toString, right? That toString method is available in the exception class, and then so therefore it's available to us in the negative payment exception through inheritance. But if we do that and we run it here, we don't really get a whole lot of information. So how do we fix this here? what we will do here is let's say come back to our exception class. So let's override this public string toString method, right? And what do we want to print? We want to return actually error cannot take negative payment. Okay, so this is what we want to have happen. In fact, we don't want to say it here. We want to put it in the toString method. So we only want that error to come up in the toString. And now we run this, enter the negative payment. There we go. Okay, so, and it's redundant here because we have this message right there. So we're just kind of optimizing everything as we go along. Enter payment out -25. Error cannot take negative payment. Okay, one last thing here is let's actually output to the user what the value is, what was actually negative. So to do that, when we create the exception right here, let's pass the value, and then in here in this constructor we'll then take that value. Now if we want to print it in the toString, how do we do that, right? How do we get this variable, because this is local to this block, how do we get this variable inside this method? Well, to do that we need to have a variable outside the methods. We need to have a class variable, and then as you can imagine we'd say this.payment equals payment. So this class variable is equal to the local variable. Now when we create the toString, call the toString method, we can then print that payment. So error cannot take negative payment, and then we can then concatenate the payment variable. Okay, now let's run this again. Enter payment amount. If it's 50, everything's good. If it is negative, if it is negative 30, error cannot take negative payment 30. Okay, so we've handled the exception as much as we would care to do at this point. Let's just optimize this a little bit more. And for example, if we get a negative payment, let's ask the user to enter a payment again. Okay, so that's gonna require a loop, right? So what we want to do is actually indent all of this. In fact, this step 3 is what this try catch is all about. So we want to put all of this inside a loop. Now what kind of loop do we want? Do we want a for loop, a do loop, a while loop? We don't want a for loop because we don't want to necessarily iterate a certain amount of times, and we don't necessarily need a while loop because we want to enter it right away. So we want a do loop. Do loop. We're going to input everything inside this do loop. Now when do we want to execute? When do we want to get out of this loop? Well, we can do it a couple of ways. One way we might want to do it here is say let's say we have a variable up top which we will call Boolean positive payment, and we'll initialize it to true. Okay, so we'll assume that this is true, and as long as this positive payment is not true, right? As long as it is not true, then we will want to repeat it again. That should make sense to you. But when do we change it then to being false? So if this, right? So if we get inside this try catch, and if this is negative, then we're going to catch it here. Then what we want to do is then say this positive payment variable is then equal to false. Okay, so let's run this again. First, let's check the good path, which is 45, and program ends. In fact, let's do this, right? Let's print when we're done. Let's say thank you for your, right, so this is actually, yeah, this all should go. This is step 4. So just so we know, right, that the payment went through, right? Don't want to just assume that because there was no error that it went through. Once it's done, then we should say thank you for your payment of, and we will concatenate the payment amount. Alright, now let's run this again. So we want to make sure that everything's working. Okay, good. Now if it does not, let's say enter payment amount is -25. Error can't take payment -25. Okay, and then now what's going on in the program? Well, we don't really know because we didn't really give any information here. If we have a negative payment, then we are switching payment to false, right? So then this should loop again. Let's see, we didn't actually get out of the loop, and that is because, let's see if it's still running. Yeah, it's still running. Okay, so something's going on here. The program is still running, and the reason why this didn't look right is because we were asking the user out. So we only asked the user once, right? So we actually want to ask the user inside the do loop. So every time we have to loop through it, we want to ask them again. So we want to say -30, enter payment amount -25. Okay. Okay, so this is looking good. Let's just add one more line here, and let's say, right, if we catch it negative, we say, please try again. Right, so there we go. Now we can run this here. So again, 40 is working good, and we have -30, okay, -25, -50, good. If we have a positive payment of 25, something's wrong here. So we had a positive payment, but we're still looping through. Why is that? Well, because when we get inside the loop, the positive payment is true, right? So as long as this is false, it's looping through. We only have one time where we are reassigning the value of positive payment, and that's right here. So we want to say if this is negative, if this is less, then we throw the exception, then we redefine the exception here. Otherwise, what we want to do is we want to reevaluate positive payment equal to false. I'm sorry, equal to true. Now this should be able to work just fine. So enter payment amount 50. There we go. Enter payment amount -25. Okay, there we go. So -50, -35, 30, and then we take a positive payment of 100. Thanks for payment of 100. There we go. So we spent more time here on actually how to write in the program flow of the application. The main thing is how do you actually write your own exception. So that's the main thing we wanted to talk about here. Should make this ... And again, here basically there's two steps. One, we have a constructor that takes the value that would throw the exception, and then we define class variable, and the constructor then would do, what do we do in the constructor? Well, we assign value of local variable to class variable, and then finally, of course, we have our we override the toString method to include the specific exception message. So it's pretty simple. We just have our constructor where we're going to pass the local variable to the class variable, and then we override the toString method and give information about our exception. Okay, so that's how you create a user-defined exception.